So as we continuing, we are talking about the pH and pOH of an aqueous solution, and we define pH as the negative logarithm to base 10 of the hydrogen ion concentration. And so mathematically we can say pH is equal to negative logarithm, right? Log, negative log to base 10. What is it to base 10? You know. So please we add it. That is it. So this will be our reason. Mathematically, we can also say that mathematically we can still write pH cannot be equal to all over. Now, if mathematically and the negative logarithm is the base 10 of the
Sir, sir, please, I can't hear what you're saying. Sir, please, we can't hear you.
hello, Maureen. Hello.
Hi.
Can you hear me now?
Yes, sir.
Okay, so as I said, so the pH, this is the pH. Finding the pOH is similar to the pH, just that we are talking about hydroxide ion concentration. Are we getting it? So the pOH would have to do with the negative logarithm of the
So your voice is
hydroxide
breaking.
ion concentration. He said, so this can give us mathematically, this, we can also represent this as negative log of 1 all over. So that is it. Now, the lower the pH or pOH, the higher the hydrogen or hydroxide ion concentration. So the lower the pH or the pOH, the higher the hydrogen or hydroxide ion concentration. It's just simple. It's just simple. You realize that when our pH, if our pH is 1, then it means that the acid is strong, and as a result, that means we have more acid concentration in the distance. We have a higher acid concentration. That's what it simply means. Now, we can all bear with me that the acid, the entire distance, what we call it, when we're doing the scale, we said that the scale is from 1 to 14. So finding for the PKW is equal to negative log 10 kW, which is equal to 14. So this means that pH plus pOH is equal to 14. Is equal to 14. 14. So when we're doing the kW, we realize that the kW, we're given the kW to be 1 times 10 to the power minus 14. And when we divided, we're able to get 1 getting 7 and 1 getting less than. Now find the pH of the kW in general. And you know the kW is an entanglement of, I've used the English song, it's an entanglement of the two, H plus and OH. You get it? The marriage of H plus and OH. And so then that means just looking at it, you just realize that one and so finding for pKW, that means the pH of ionic product of water, we are giving us negative log of the kW, and already we know the kW. We are given the kW, the value of kW we know is a constant. So when you factor the constant here, we are getting 14. So the 14 just simply means that pH, that means the pH of acid plus the pH of water should give you 14. Are we there? Just as we did for this thing. So basically that's what it means. So as just this simple basic formulas that we are going to use in any calculation you are given. Maybe when you're asked to find for, calculate for the pH of this, calculate for the pH of this, calculate for the pOH of this, calculate for the concentration of this. It's just this basic formulas we've learned that we are going to use to calculate. Now let's try a typical example. My back is aching. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Let me sit. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Please, are you writing? Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Calculate the calculate the pH of aqueous solution. Are we there? Calculate the pH of aqueous solution of 0.0003 molar. M, that's capital M. Calculate the pH of aqueous solution of 0.0003 molar hydrogen ions. Calculate the pH of aqueous solution of 0.0003 molar hydrogen ions. Are you there? Oh, mine means more.
No, sir. I didn't hear the question.
Let me repeat it. I said calculate the pH of aqueous solution of 0.0003 molar. The molar is capital M. Hydrogen ions. Hydrogen ions. So please, who can solve it? What are you getting? Who has been able to solve it? What are you getting? Or we should solve this one. So looking at the question, we are given a concentration of the hydrogen to be what? Someone should tell me here.
0.33, 0.0003, which is
So
3 times 10 exponent negative 4.
get your bean. So there's a concentration we're giving for water. So if there's a concentration we're giving for water, and the question says we should find for what? The pH of the aqueous solution. So the pH of the aqueous solution, we already know the pH, the formula for pH. pH. Just having the H crash will tell you which is the pH of that. So pH is equal to what?
Maureen, yeah, please. My DMY.
So this is equal to H plus. And the pH is equal to minus log H.
Yes.
So pH pH is equal to the negative log of the concentration. What the concentration are given to be 0. What?
0.3.
Those are the calculator. What are we getting?
3.5229.
3.5. So we are getting this. So this is so this is a pH. Now when you get a pH like this, it's less than 7. So that means this pH is what? So that means this is what? So the what's the it's acidic, right? Oh
Yes.
Yes, sir.
it's acidic. Okay, so let's try and do some.
Yeah.
What is the hydrogen ion concentration? Let's try and see if you can do this. What is the hydrogen ion concentration? 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 What is the hydrogen ion concentration of solution? What is the hydrogen ion concentration of solution? Whose pOH is 11.5? What is the hydrogen ion concentration of solution whose pOH is 11.5? Whose pOH is 11.5? What is the hydrogen ion concentration of solution whose pOH is 11.5? Let's do it. I'm waiting for the answer. What is the hydrogen ion concentration of solution whose pOH is 11.5? I'm waiting for the answer. Who is done? Asha, are you done? Asha, are you done? You said?
Not yet.
Oh, okay. Christabel, Ahiale. Christabel, are you done? Christabel. Comfort, are you done? Connie?
I'm waiting for what's answer, so
Yeah, Christabel, no.
I'm waiting for Maureen's answer. Say my yo, but
Mate, come
me
on.
who say
Mate,
like
Mate, see connect. Why? See connect. See connect. See connect no even mind me. Benedicta appear. Bene,
Yeah.
Bene, what did you get?
Sir, please. I'm waiting for someone to first say the answer. Just to see.
Benedicta. Bene plus Dick plus star. You are not still done. Uh, Equia. What do you get? Parley biscuit. Maureen.
yes, sir.
Yeah, he did. I have to come to you. Maureen, what do you get?
Say me I had 3.162 times 10 exponent negative 3.
Clap for it. So what did you get? Asha Wale. Asha. Oh, won't Asha mind me? Millicent, what did you get? Okay, so those of us who didn't understand, let's do it. The question says that, Maureen, how did you do it? Maureen, how did you do it? Tell us how you did it.
Say please. You see, pH plus P. We were given POH as 11.5, but we are finding hydrogen ions, which is H plus. So first we have to find the pH, and you give that pH plus POH is equal to 14. So you fix in the POH and make pH the subject. You get 2.5. After that, the pH is equal to negative log H plus. You substitute and make H the subject.
Good girl. So let's try it. I hope you all got a. So we are given this formula, and the question we are given hydrogen ions, and so that means we can't use the one we are given. The one we are given was the pH of OH ions. So to find for pH of the hydrogen ions, we subtract that which we were given from 14. And so we are going to get 14 minus the 11.5, which will give us the 2.5. Now from there, the question says that we should find for, what is the hydrogen ion? So we have to find for the concentration. But we know that pH is equal to negative log of H ions, of H. Then we are looking for H. Already, you know we are looking for H. But this one is log 10, log base 10. And by God's grace, we've been able to get the pH by deducting that of the POH from 14. So we had 2.5. 2.5, right? 2.5. So we can get 2.5 is equal to negative log 10. So we can get this. So after getting this, then we are looking for this. We are looking for the concentration. So what we do is per logarithm formula, because there is negative, you will just negate this one so that we can do away with the negatives. Then we per logarithm, this this will be, if you want this to stand on its own, this will raise to the power this. So then we are going to get 8 is equal to 10 raised to the power
Mm.
10 to the power minus 2.5. What's the answer? So we had 3 points this thing, signifying that this thing is an acid. So if per exams, if you are giving this thing, if exams you are giving work and you go and write, we have to find for pH and you go and write 8 point something, your answer is wrong because you are finding pH and you know pH should be below 7. Are we getting it? Are we getting it?
Yes, sir.
Yes, sir.
Good girls, good girls. Okay, let's try this. Calculate the hydroxide ion concentration. Calculate. A typical Ashanti man will say calculate. Calculate the hydroxide ion. Calculate the hydroxide ion concentration. Calculate the hydroxide ion concentration at 25 degrees Celsius. At 25 degrees Celsius in a solution whose pH is 5.78. 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 Take Kw, which is the ionic product of water, to be 1.0 times 10 to the power minus 14 mole square dm minus 6. Take Kw to be 1.0 times 10 to the power minus 14 mole square dm minus 6. Start work. Marlene. I'm a benzo. Jubilee House. Jubilee. Who is done? Asha, what did you get? Baby girl, I've missed you. Come and give me a hug. Is that I've missed you? Come and give me a hug. Charlie, Asha, what did you get?
Sir. Sir.
Yo.
Six point zero 6.02
6.0
26
6.0 6.026. Okay, times
10 to the power negative 9
that's my
more
boy, that's my boy, that's my boy, that's my boy, that's my boy. That's my boy. Millie, what did you get? Millicent, what did you get?
So I had 6.02 times 10 to the 9.
That's
Negative
my
9, sorry.
that's my girl. Charlie, I love you so much, Kay. I love you so much. Yeah.
So but my name is not Millicent.
Your name is Millie, right?
Yeah, no good.
Ah, Mildred. Oh, baby girl, I love you so much. Yeah. Cindy, baby. Cindy, baby. Cindy, baby. Get your network in it. Message now. Go and come and leave our Makari, okay? You get good network. Or Tantra. Maureen, what do you get?
So please, I had the same thing.
That guy. Say, please, I had the same thing. Okay, let's do this one. Maureen, my baby girl, I love her so much. Let's do this. I hope you all understand. Let's try this. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution. Calculate the pH of aqueous solution of 0.05 mole Dm-3 of 0.05 mole Dm-3 of HNO3. That means that's triosonitrate 5 acid. So calculate the pH of aqueous solution of 0.05 mole per dm cube of HNO3. HNO3. Start work. I don't want us to solve questions so that I'm convinced that you understand to that point. Then maybe some other time we can continue. We can continue. When all my friends go away, I'll be glad to say, hey, you're still lead me. Even when the wind blows by, I still feel warm inside. When you pray, pray for strength. I'll help you carry on. And troubles come. What are you getting? Okay, what did you get? Okay, what did you get? When you dream, dream big. Okay, what did you get? Mildred, what did you get? Mildred, what did you get?
So please, I'm not done.
Oh, okay, okay. You're not done, okay. Marlene, what did you get?
Say, say you, say, say the answer I had name. So you the left of.
What did you
Yeah, I'm
get?
waiting for this.
What did you get?
Say 1.301.
My girl is good. My girl is good. My girl is good. Ah, ah. How have you been saying ah? Like these girls are mad. You know, say ah. The way some will say that it's as if something is happening. Maureen, you're a bad girl.
Oh, say.
A bad girl. Mildred, what do you get? Okay, it's the same thing. So we are giving 0.05. You said we should find for pH, and we are giving the concentration. And just seeing the HNO3 just to tell it's an acid. So we just use the formula. You don't have to minus log times this thing. You just don't have to worry yourself. Now let's see if you can do some advanced this thing. We just have some few minutes to go. Calculate the amount of OH ions. Calculate the amount of OH ions present in 250 cm cube of a solution. Calculate the number of OH ions. Calculate the number of OH ions present in 250 cm cube of a solution. Calculate the number of OH ions present in 250 cm cube of a solution whose pH is free. Whose pH is free? Whose pH is free? Avogadro's number is 6.023 times 10 to the power 23 particles mole per mole. Avogadro's number is equal to 6.023 times 10 to the power 23 particles per mole. Now let me take it again. Calculate the number of OH, baby girl. Calculate the number of OH ions. Calculate the number of OH ions. Calculate the number of OH ions present in 250 cm cube. Present in 250 cm cube. Present in 250 cm cube. Present in 250 cm cube of a solution. Of a solution whose pH is free. Whose pH is free. So the phrase will just tell you that the solution is acidic. Take Avogadro's constant to be 6.2 times 10 to the power 23 particles per mole or entities per mole. Start work. That will be our last question or our final question. Today I'm feeling keke. I'm expecting my twins, so please pray for me, okay? That one won't be a boy, one won't be a girl. One will be Copac, one will be Copac lens. So just In case you don't come for my naming ceremony, I've already told you their names. Please, what are we getting? What are we getting? Let's have just one minute. When it ends, we are not coming again. Do it and put it on the platform. Now, what did you get?
Sir, please, I'm not done.
Okay. So this one, before you can get this in the concentration, you know how to. This in the OH, you can get the OH ion from subtracting